So this is unit exponential and logarithmic review for the midterm. So question number 1 says if log base 3 of 5 equals 3y and log base 3 of 4 equals 2x and log base 3 of m squared equals 6, then we're going to use the expression log 3 bracket 100m to the power 4 to write an expression with only x's and y's. So we need to replace all of this with only x's and y's. There should be no logarithms by the end of it. So what we want to do is we want to start by writing out this in terms of these two numbers. We want to look for values that can multiply up to 100. That could be 5 to the power or 4 to the power. So for example, log base 3, I'm going to use the values of 25 multiplied by 4. 4 is the same value that I see right here, and 25 can be written as 5 to the power of 2. So my goal is to get always them to have the same bases as what I see right here. Okay, and then I should still have that bracket with that multiplication of m to the power of 4. Okay, so my next step is to split them up. So I know that logs, whenever they multiply, can be added. So I'm going to split up 25 plus log base 3 of 4 plus log base 3 of m to the power of 4. So those are all multiplying, which means that you can add between the different logs. The next step would be to write log base 3 of 25. Instead of 25, we're going to write it as 5 to the power of 2. It still means 25, but what I'm trying to do is I'm trying to get it to look like log base 3 of 5. Next, log base 3 of 4, I'm going to leave it because it looks exactly like I have over here, this same term, so that's a good thing. Plus, log base 3, I want m squared. I need an m squared, so instead of m to the power of 4, I'm going to write m to the power of 2 to the power of 2. Next, we're going to use the power rule. The power rule states that I can always bring these powers in front. So it's going to be 2 log base 3 of 5 plus log base 3 of 4 plus 2 log base 3 of m. Next, if you look, you'll see the same expression here and the same expression here. And we have the same expression here, same expression there. And finally, we have the same expression for log base 3 of m squared. Oh, and there should be a little 2 there. And then we have the exact same thing right here. So when I brought down the 2, I was left with m to the power of 2. So what I'll do is I'll replace the red with 3y because I know that log base 3 of 5 is the same as saying 3y. Log base 3 of 4 is the same as saying 2x. And log base 3 of m squared is the same thing as saying 6. Lastly, I'll simplify by multiplying 2 times 3 together and 2 times 6 together. So that's my final expression. That's in terms of x and y, and it still represents what log base 3 of 100m4 would equal to. Example number 2. The sound of Ellie's farm tractor is 63 times as intense as the sound of her car. The tractor, from that sentence, I know is louder than the car. When you have a whole number for your intensity, when you're comparing the intensities, you always want to have the stronger item at the top. We don't know what the decibel level of the tractor is, so we're going to have that at the very top of the fraction. We're going to go x, we're going to go 10 to the power of x, because all sound and earthquakes can always be written as 10 to the power of x, divided by 10 to the power of the car. So the car decibel, we're going to always divide our decibels by 10, so that's actually going to equal 10 to the power of 8. So always decibels, you divide by 10 to get the powers. And then when we compare them, we know that the tractor, which is the top, the X, is going to be 63 times stronger than the car, which is at the bottom. So this is the expression that we need to solve and use for X. So what we're going to do is we're going to multiply both sides by 10 to the power of 8. So I'm going to multiply this side by 10 to the power of 8 and this side by 10 to the power of 8, which cancels those out. 10 to the power of X equals 63 times 10 to the power of 8. It's a very big number, so I'll leave it as it is. Next thing I want to do is I want to write this as a logarithm. So I know that it's always the power, which is X, equals log base 10. We don't have to write log base 10. And in brackets, we're going to write 63 times 10 to the power of 8. And then we're going to put that in our calculator. So we're going to go and put log 63 multiplied by 10 to the power of 8. And I get that it's 9.8 if I round to the nearest tenth. Finally, when we get this, this is not the decibel level. So what we have to do is multiply by 10, because if you look, remember, to get our power, we had to divide earlier by 10. So now we're going back to decibels, so we have to multiply by 10. So that's going to be 98 decibels. And that makes sense because it's larger than the decibels of the car. So this is my final answer. Question 3. Some strains of E. coli can cause serious food poisoning in humans. Suppose a biologist originally estimates the number of E. coli bacteria in a culture to be 1,000. After 90 minutes, the estimated count is 19,500 bacteria. What is the doubling period of the E. coli bacteria to the nearest minute? So we're going to use the equation A equals A0. Whenever it's doubling, we put a 2 as the base to the power of T over the doubling period, D. So we know that initially there was 1,000 bacteria, and we end up with 19,500. It takes us 90 minutes to do that, so that's what T is equal to. We're actually looking for the doubling period, which is the letter D in this equation. So we're isolating for D. One way to do that is we can go y1, y2, find the intersection. Another way is to solve this algebraically. We can divide the right side and the left side by 1,000. So that's going to be 19.5. Next, I can change this to a logarithm. It's always going to be your power is equal to log of your base, in brackets, 19.5. The next thing I can do is these guys can swap locations. So if I know that if I multiply by D and divide by log base 2 of 19.5 on both sides, it's going to look like this. And that's equal to D. So I isolated for D by rearranging the equation here. And then I'll put that in my calculator. So 90 divided by alpha window number 5, put log base 2, and in brackets 19.5. Okay, so I get that it's going to take 21 minutes. Okay, so 21 minutes for your item to double. So every 21 minutes, your bacteria doubles in number. So it started off as 1,000, then it went to 2,000. Okay. Number 4, how long will it take for money invested at 5.5% compounded semi-annually to triple in value? So this is where we use the equation A equals P, 1 plus I. Whenever there's compounding, we divide by C to the power of N multiplied by C. Okay, so it doesn't matter what we put as our principal, our initial amount, as long as we triple that value. So I could put 100, I could have put 1,000, as long as I triple that, meaning I multiply that value by 3 in my A value. Then it's going to be 1 plus your percentage. You're going to change it to a decimal by dividing by 100. And you're going to divide it by your compounding, which means semi-annually. That means twice a year. And then here, if I want to find my years, you're going to solve for n. If you want to solve for your just the value in compounding in semi-annual periods, you can just put n, because this will represent semi-annual periods. Okay, so semi-annual periods would be your n. Now, if you put the c value there, meaning if you times it by 2, that's going to solve for the n will represent years. Okay, so first, what we're going to do is we're going to simplify this by putting that into our calculator. So it's going to be 3,000 equals 1,000. My calculator. I'm getting 1.0275 to the power of n. Next, I can divide both sides by 1,000. And now I'm going to put log on both sides. So this is just another technique for solving. I can still solve by changing it to a logarithm itself, or I can just put log on both sides, just for practice. Next, we always bring the powers in front. So the power of n is going to become a coefficient. And we're going to divide both sides by log 1.0275. And we're going to put log in our calculator, 3 divided by log of 1.0275. So I get 40.5 if I round to the nearest tenth, and this is semi-annual periods. Semi-annual periods. So if you wanted the answer to be in semi-annual periods, you'd say 41 semi-annual periods. You'd round up. If you wanted years, you would take this number and divide it by 2. Okay? So this is my final answer, semi-annual periods. Number 5, you want to describe in order a series of transformations that could be applied to graph y equals log of base 5 of x to draw the graph of each function. So we're just drawing this one here. What you could do first is you could factor it if you want to describe the transformations. Okay, so A, we're going to describe it. So we know that there is a horizontal stretch about the y-axis by a factor of 1/3. So we always flip that. We always do the reciprocal when we have that horizontal stretch. Next, we're going to do a reflection about the x-axis. And then we're going 12 units to the right, so we have a horizontal translation. Units right. And we have a vertical translation. Two units up. Okay, so that's our description. Next we're going to sketch it. So we're going to put this into our graphing calculator so we can put the original one in there. Okay, so to put this in, we're going to have to press negative alpha window number 5, base 5, and in brackets, we're going to put that 3x minus 36. And outside the bracket, we're going to add 2. Okay, I'm going to use the standard window for this, and then I'm going to graph it. So what you'll notice is that if I use the standard window, it won't see it. The reason being, if you look, remember the horizontal translation was 12 units to the right. Normally, we have an asymptote over here when x equals 0. But if there's a horizontal translation, it's going to move with it. So now it's going to be 12 units to the right. So now our whole graph has moved 12 units to the right. So our standard window isn't enough. So I go to the window. Instead of stopping at 10, let's go up to maybe 20 and graph it. Okay, so that will work. For some reason, it's not graphing properly in mine, so I'll go to Desmos. But if you set your window, so I'll write down the window that you should be seeing your graph in. So if you use, guys, if you use the window for x from 0 to 20, going up by 1, and for y, if you just use that standard window, you should be able to see your logarithmic graph. So I will do it in Desmos, but again, you should be able to see it graphically if you do it on your graphing calculator. So I just tested out on my calculator and it did work in that window. Okay, so y equals negative log . Okay, so as you can see, that window would have worked here. So this is what I'm graphing. So when you guys see it, what you'll notice is it looks probably like this. It looks like it stops here, but you need to remember that it extends upwards, right? So if you look at it, it does have that asymptote, that vertical asymptote at 12. Now then you'll press, in your graphing calculator, you'll press second trace. So I'll write down those little steps for you. So to get your x-intercept, so if I'm doing E, you're going to press second trace number 2, enter, and then you're going to go to the left side, the right side of it. And once you go to the left side and right side of it, you should find that in your left bound and right bound, and you press enter, your x-intercept should be 20.3 repeating. So 20.3. Your y-intercept, there should be none. It should not touch your y-axis. And then what you'll do is you'll change your scale, 5, 10, 15, 20, 25, and then you'll plot that. And then you'll just make sure that you have that vertical asymptote. So again, it's not mandatory to draw that vertical asymptote, but it might help you sketch it properly. Okay, so it should look like something like this with arrows on either side. Okay, so we sketched it, and then we're going to do the domain. So I'll do the domain next because I like to always see it first and look at kind of the x-intercepts and y-intercepts first. So my x-intercept, or sorry, my range and domain. So the domain for this will be where x such that x is greater than and not equal, so greater than 12, and then it'll be xer. Okay, so we know that it's going to be greater than that vertical asymptote, but it doesn't touch that vertical asymptote. And your range for logarithms is usually y such that y is an element of real numbers. And then the equation of our asymptote, it's a vertical asymptote at x equals 12, and that came from our horizontal translation. So remember we said there was a horizontal translation of 12 units to the right, so our vertical asymptote, which used to be at x equals 0, now moved to x equals 12. Okay, so that is question number 5. I'm kind of annoyed that this one didn't draw. Boo. Boo you. Yeah, there's nothing wrong with it. Oh well. Such is life. There's an invisible graph apparently. Okay, so our last two questions are asked to be done algebraically. So you're going to determine the value of x. So this is A, this will be B. So for A, first you're going to group the logarithms on one side of the equation. So I'm going to move them to the left side by adding log base 2, x plus 2. The 4 stays on the right. Whenever there's addition of logs with the same bases, you can multiply using the product law. These two will multiply. Next, we change it to exponential form. This is your base. So 2 to the power of your answer, 4, equals what's inside those brackets, x minus 4, x plus 2. 2 to the power of 4 is 16. And then you're going to FOIL that, x squared plus 2x minus 4x minus 8. I'm going to simplify. Like terms, minus 2x minus 8. And then we're going to subtract 16 on both sides of the equation. Okay, so we want to find two numbers that multiply to negative 24 and add up to negative 2. So that would give us x minus 6, x plus 4. So our solutions are x equals 6, comma, x equals negative 4. The negative, if you look at it and even check, it will not work because negative 4 at the top plus 2 inside the bracket. So if I substituted this guy as negative 4, you're going to see that the bracket equals a negative, which you're not allowed to evaluate. So the only answer that's possible is x equals 6. B. Step 1, we're going to put a log on both sides. Next, we're going to bring those powers in front. And then we're going to distribute the logs into that bracket where those become the coefficient. So x becomes your coefficient, log 12 minus 2 log 12. And then the same thing here, 2x log 3 and plus 1 log 3. So we're going to bring the x's to one side of the equation. So I'm going to bring this x to the other side. It doesn't matter which side you bring it to. These guys cross off. And I'm going to bring this 1 log 3 to the other side by subtracting. Now you can't actually subtract those logs, so you're just going to write them side by side. So minus 2 log 12 minus 1 log 3. And then you have on the right side 2x log 3 minus x log 12. So these guys crossed each other off. Okay. So as you can see, your goal is to isolate and have the x's on one side, non-x's on the other side. So we're going to leave the left side as it is. On the right side, we're going to factor out the x. That's common. Everything around it stays the same. So instead of 2x log 3, now we have 2 log 3. Instead of x log 12, we have just log 12. Lastly, we're going to divide both sides by that 2 log 3 minus log 12. Okay, so in your calculator, when you do it, so to make sure you do this properly, put brackets around this, and then separately put brackets around your denominator to make sure you don't make a mistake. Okay, so I'm going to put bracket negative 2 log 12 minus 1 log 3. You don't have to put the 1 in front of it because it doesn't change its value. And then bracket, when I divide, bracket 2 log 3. Always close your brackets after you do those 3s and 12s, minus log 12. Close your bracket, close your double bracket, and then you should be getting that x is equal to 21.09. Okay, it doesn't say what to round to, so you can have just 21 or 21.09, or just, you can have more decimals, but that's it. Okay, so that is the only answer. You can always check algebraically or graphically, sorry, by putting the left side into y1, the right side into y2, and then the intersection is your answer. Okay, so 21.09. Okay, so that's it, folks. I will maybe see you tomorrow or talk to you guys or